Hello students, welcome to the course on Hydropower Engineering GEH 301 offered to students of Engineering Geology program during 5th semester. I'm Kirtan Adhikari, faculty at College of Science and Technology, Royal University of Bhutan.
Welcome back, students. So here we'll be discussing about the hydropower scheme. In general, we'll be discussing about the layout of hydropower plant. As you know, there are many components of hydropower plant, and it always starts with the reservoir, whereby we construct a dam to store water temporarily, and then that water is taken to the powerhouse, whereby the electricity is generated, as you can see in this diagram. Here you can see that dam is constructed, whereby there is a reservoir because of this dam, and there's intake facilities whereby all the dirts and the unwanted materials are all removed at this point, and finally goes towards the headrest tunnel finally, and it is conveyed through the pressurized pipe, we also call it penstock, and then it reaches the turbine, whereby it is the water turns the turbine, whereby the turbine generates the turbine in turn turns the generator, and then electricity is produced, and finally the water is drained through tail race tunnel. And in plains like in India, usually this water is taken to irrigation canals, whereby the water can be used for agriculture, but in Bhutan that is not the case. It is drained back to the river system. If I go in detail of how exactly things work, then it's something like this. First, the water is, like I explained, what dam is constructed across the river, reservoir is formed, and the water from the reservoir is first taken to the now I'm particularly talking about the scenarios of hydropower plant in Bhutan. Okay, this slide is much more it talks about the hydropower plant. Overall, it gives you a perspective, it gives the overall layout of a hydropower plant in Bhutan. Okay, so whereby the water from the intake facility is taken to desilting chamber. So desilting chamber is a huge chamber, in fact, okay, where the silt, the minute sediments that is in the river, usually our rivers is in mountainous terrain, it carries lots of sediments, and when it the sediment hits the turbine, it deteriorates the turbine. That's why we have to get rid of such sediments. So desilting, it first goes through the intake facilities, whereby all the dirt and unwanted materials, huge logs, boulder, plastics, and so many other unwanted materials are drained. It's segregated. The water is still containing huge amount of sediments, and that sediments is it's we try to remove the sediments in desilting chamber. It's a huge chamber where the water is kept at a very, very low velocity. When the velocity is almost to zero, then its material, the sediments, tends to settle down, and thus we get rid of the sediments, and then the water is taken to the powerhouse through the penstock, and that pipeline is what we call by penstock. Okay, and that water which is flowing through the penstock is in huge with the huge velocity. It flows with a very high velocity, and when it strikes an impulse turbine, then it makes the turbine rotate. Okay, so that's how things work. And here in this example, the powerhouse and a dam is constructed together, but it depends upon the topography where you want to construct the powerhouse. Now, for a relatively rolling terrain like in India, a flat terrain, powerhouse and the dam are usually constructed together. But in our case, the powerhouse is usually constructed way downstream of a dam, because we get a gain in head. We know that our topography is mountainous, and it is very steep terrain we have. So if a dam is constructed upstream, and we even if we travel 1 or 2 kilometers downstream, then the elevation difference is a lot. There's a large elevation difference, so it is advantage in that sense that we get enough head to generate more power. So usually in the case of Bhutan, the powerhouse is constructed way below the dam. If I give you an example, the Chuka Dam is way above the, where the powerhouse, Chuka powerhouse is. If you remember, the Chuka powerhouse is located exactly in Chuka town, right? It is visible from the Wangkai region, but the dam is way upstream of the Chuka bridge, as yes, you must be knowing about it. So why the powerhouse is constructed downstream is because we get the elevation difference, and that elevation difference between the dam and a powerhouse is what we call by head, and we are going to discuss more about it later. So with this, let's continue. And yes, now the next topic that we have to discuss is the head. Like I said, there's a reservoir, and from the reservoir the water is taken to the powerhouse, and where the power is actually generated. Okay, so this is the schematic of a powerhouse, total hydropower plant. Now let's try to understand the heads. So this is the total energy line. So this dotted line shows the total energy line, and it's sloping downwards because there's always some frictional losses as the water travel from the reservoir to the powerhouse. So there's always some losses. And let's say this is the reservoir, as I've already explained. I will explain much about this surge tank. There's a small tank being constructed. We'll discuss more about the surge tank, but right now just understand there's another component, a surge tank, and it is different from desilting chamber. Okay, desilting chamber would be right close to the reservoir. Here desilting chamber is not shown, but there is a desilting chamber somewhere here. And the pipe that carries the high pressure water to the powerhouse is what we call by penstock, right? And there's a spear to control the flow volume to the turbine. And the total elevation difference between the point at which the water impinges, the jet impinges on the turbine, and the reservoir level is what we call by the gross head. That is the total head. And the head that is actually available at the point where it impinges the turbine is what we call by the net head. By definition, the gross head is the total head, or the elevation difference between the powerhouse, or where the jet strikes the turbine, to the tail race level, or the intake level, you can call it. And the net head is, as I explained, is the actual head. And the difference between these two is what we call by the losses, and there can be different types of losses. Okay, so head loss in the penstock is because there is a friction, right? Water has to come through the pipe, and the rim of the water touches to the rim of the pipe, so there is always some frictional losses. And head loss and the nozzle, so when this water is converted into jet, and there's always a minute fraction of losses because of the eddies formations. And also there's an hydraulic losses when it impinges the turbine. So these are some of the losses to quantify, and with this losses, the net head is always less than the gross head in a hydropower plant. With this, let's try to understand the functions, and we'll be discussing more of surge tank, but right now let's understand what exactly is a surge tank. So here is again one more schematic of hydropower plant. So there is a reservoir, and there's a intake facilities, and here somewhere here it will be desilting chamber, and this is what we call by penstock. Now what happens is, if during the power generation, so here this is the powerhouse, and here is the turbine. So when we need to shut down the powerhouse, first let's say we are going to do some maintenance, and we need to shut down the turbine. So at that time we'll be closing the valve right here, right? The valve that is okay. So let's say there is some valve here. So if we close this valve, what happens is water is flowing with tremendous velocity, like I have explained here, right? The water is flowing with tremendous velocity. So when velocity at this point is suddenly made zero, then what happens is, because of the momentum, there will be immense pressure rise in this section. Because of this pressure rise, there is a chances that these pipe, okay, this penstock, let's say penstock, there is a chances that this penstock may burst open because of the internal pressure. So we have to think about a way to reduce the pressure. So so for that reason, a surge tank is constructed nearby the powerhouse, okay, quite nearby a powerhouse. So what happens when you shut down this valve, of course water cannot flow, but water will then rise up to the surge tank, and the level of surge tank will increase. And when the level increases, the pressure, of course the pressure will increase, but it is not going to increase significantly. And the piping system, internal piping system or the canal system, is safe. So because of this reason, the surge tank is constructed. Okay, so this is the main function of a surge tank. I have explained that in right up here, you can go through it later. So that is the main purpose of a surge tank. And like I explained previously, there is always energy losses. So let's understand in detail what are the losses in hydropower plant. So as the color coding here states, there's a high energy, right? The gross head, which we call it, when at the reservoir level, we call it the gross head. And as it moves, the water moves from the dam or the reservoir towards the powerhouse, gradually the energy also decreases. And at different location, there are different types of losses, like in the headrest tunnel, where water is flowing through the tunnels and the pipes, which we call it penstock. There's always a head loss, as we call it the frictional loss. There's always a friction. And when it enters, here I have written the spiral casing. This spiral casing is for the reaction turbine. We'll be discussing more about this impulse turbine and a reaction turbine later in our course, but let's understand that all the turbines are not exposed like Pelton turbine. Pelton turbine is a different type of a turbine which is exposed in open air. So jet forms and jet strikes the blade and then it rotates. But in case of a reaction turbine, it is not the case. The working principle of the turbine is slightly different. So here is a different type of turbine. For now, just understand there is a different type of turbine. So when it passes through the turbine, there is always the eddy formation, and there is always losses in the draft tube. So likewise, there is the losses of energy, which we call it losses generally. Excuse me. And then finally, when turbine rotates, the turbine and shaft are connected, and this shaft turns the generator, and there is always some mechanical losses between the bearings, because it's our mechanical movable parts, and whenever movable parts try to it tend to get grinded, kind of a thing. I'm sorry that grinding term may not be true here, but you just try to understand that how the ball bearings works. So when this ball bearings, when the turbine rotates the shaft, and then shaft in turns rotates the generator, there is always a movable part, and this movable part, there will be frictional losses. Okay, it's different frictional. Here the friction is between the movable parts. Here the frictional loss is the frictional loss in the liquid. Here it is not in the liquid. Okay, so with this, I would like to end my lecture here. So with this, let me end the lecture here, and we shall continue the lecture. Thank you.